Good evening and welcome to electrical engineering class. This is section 3 of the class. A quick review. Last week we discussed about induction motors and how to calculate their full load current. I promise of coming to you this week with how to calculate a full load current of generator set. How to calculate generator full load current. So today, all what we are going to look at is to how to calculate the problematic aspect of generator set. Why is it important for us to worry ourselves? To talk about this. It is very crucial and it's very necessary in knowing how to calculate generator's full load current because one, it influences one's decision on what load to be put on the generator set. Secondly, it also influences you, the practitioner, the electrical practitioner, your decision in your choose or in your quest to select even the breaker type for the for the load. Because if you know the load, the current rating of the generator, this is where it will positively influence you to choose the right protective device to be used. So this is why it must be of necessity for us to know how to calculate the full load current of generator. There are a lot of reasons, but I'm only giving out these 2 points to equip and also to aid us to do our best to calculate for a full load current of a generator. Generator set can either be 3-phase or in single phase. Either it will be 3-phase generator or it will be a single phase generator. Secondary. So this is the parameters that you need to consider if somebody asks you, okay, calculate the full load current of a generator. First of all, what have to come to your mind first? What is the phase of the generator? Is it a single phase generator or a single 3-phase generator or a single phase generator? The second parameter, you need to look at the rating of the generator. Is the generator rated in kVA or in kilowatts? Is it rated in kVA or in kilowatt? That's kW. If the generator is rated in kVA, that's kilovolt ampere, this is the formula to be used. Full load current I represents full load current is equal to 1000.S over square root of 3 dot voltage. This is when the generator, or if the generator is rated in kVA. This is the formula. Let me define the variables. S is equal to rating of the gen. So the S in the formula represents the rating. So here we are talking about kVA, so it automatically, the rating of the generator here is kVA. The V is the voltage, and here the voltage is in volts, and also the voltage here will be V subscript LL, meaning line to line voltage. There are 2 types of voltage. We have phase voltage and line voltage. When we talk of phase voltage, it is the voltage measured between the live conductor and the neutral conductor. So the potential difference between the line and the neutral is what we call the phase voltage, and the line voltage is the voltage or the potential difference between two live conductors. It can be red and yellow, or red and blue, or if it comes to our new color coding, it will be brown and black, or brown and that of gray color. So that is line to line voltage. So the voltage here is line to line voltage since it's three phase, and the I is the full load current. So the I is the full load current. So now, since we have the formula, let us try to solve one example or one problem. Calculate So this is the question that we are being asked to solve. We have to calculate for the full load current of 50 kVA 480 volt generator. So let's quote the formula. Full load current I is equal to 1000 dot S over square root of 3 dot volts. From the question, S is equal to 50 kVA. V is equal to 480 volts. I is unknown, question mark. So now let's do substitution to the formula. I is unknown, so I remains 1000 dot. The dot here represents multiplication, so you can change to multiplication sign. The S, which is 50 kVA, so now put 50 there, over square root of 3. Voltage V, which is 480, so start with 480. 1000 times 50 will give you 50,000. Square root of 3 is 1.732 times 480. So quickly, I have my calculator here. 1.732 times 480 will give you, so now 50,000 over 831.36. So 50,000 divided by 831.36 is equal to 60.142 ampere. That's the unit of measurement of current. So now this is how to calculate for a full load current of a generator. This is when the generator is rated in kVA. So this is the formula, and we've taken the problem and we've stopped. Now let's move to the other side. If it happens the generator is rated in kW, small k, capital W. If the generator is rated in kilowatts, also this is the formula. If the generator is rated in kW, I is equal to 1000 dot S over square root of 3 dot cos theta dot voltage. So as I explained in other formula, the S also still remain for the rating, the V voltage. Here the cos theta here is the power factor of the generator set. So if you see any generator which is rated in kW, you must also look at the power factor of the generator. It will aid you in calculating for the full load current of that specific generator. So now we are not going to change the question, but we are going to add. So calculate the full load current of 50 kW, 480 volts, estimated power factor of 0.86 generator. So all what I did is to bring the power factor of the generator, since now the generator is in kilowatts. So now from the question, the rating of the generator is 50. So put into the formula 1000 times 50 over square root of 3 times the cos theta, which is the power factor in the question, is 0.86 times voltage in the question is 480. So 1000 times 50 is 50,000. Square root of 3 is 1.732 times 86, 0.86, 1.732 times 0.86 times 480 is equal to 710.016. 710.016. So 50,000 divided by 710.016 is equal to 70.42 ampere. So this is for generator set rated in kilowatts. So this is for 3-phase generator. So what is the difference for a generator rated in kilowatt and a generator rated in kilovolt per ampere? The only difference here is for generator rated in kilowatt has a power factor, but once the generator is rated in kVA, kilovolt ampere, does not require a power factor. So hence the only difference is that for generators that are rated in kVA does not require the power factor, whilst generator rated in kilowatts requires a power factor. Okay, now let's move to single phase generator. So single phase generator. Single phase. If the generator is also rated in single phase, because I made mention of 3-phase generator and single phase generator, we are done with 3-phase. Now we come into single phase. if the generator is rated in single phase and it is rated in kVA, also this is the formula. If the generator is rated in kVA, single phase generator rated in kVA, this is the formula. S represents the rating of the generator, which is kVA, and the V is the voltage. Here, the voltage will be V subscript Ln, which is line to neutral. As I said, in single phase, when we want to measure the voltage will be from the live conductor to the neutral. That's the potential difference of the live conductor and the neutral conductor. So the voltage here is line to neutral voltage. So now let's take example. I have a generator at the site, and the generator has been rated in kVA. It's 5.5 kVA, 230 volts. I'm asked to calculate for the full load current of that generator. So now you state the formula. I is equal to 1000. Now here the S, which is the rating of the generator, is 5.5. Now the voltage here is 230. 5.5 times 1000 is 5500, if I'm right. 1000 times, yes, it's 5500 divided by 230. So I 5500 divided by 230 is 23.991 ampere. So this is a generator, a single phase generator rated in kVA. If it is rated in kilowatts, if it is rated in kilowatts, if it's rated in kilowatt, then the formula then changes to 1000.S voltage cos theta. If it's rated in kW, now you need the power factor of that generator. So now this generator, we are using the same question, but now there will be an estimated power factor. PF is equal to power factor of 0.85. So now let's substitute the formula. 1000 times the rated is 5.5 over the voltage is 230 times the power factor is 0.85. So now 1000 times 5.5 is 5 times 500. 230 times 0.85 is 195.5. So 5 times 500 divided by 195.5 is equal to 28.13 ampere. So this is generator rated in kW. If it's rated in kW, which is single phase, also this is the formula. I hope this will be beneficial to all of us as we proceed to do our work. May this seem to be a great opportunity for all of us to enable us to do more and to eradicate the complications that we have. It's very simple. Try and solve more on your own. I'll come to you tomorrow, God willing, with how to calculate, how to do direct online configuration, that DOL, how to do for motors, how to start a motor on a method called DOL. May God bless you and be with you. See you tomorrow.